All right, guys, more probabilities today. Probabilities of independent and dependent events. To be honest with you, today we're going to concentrate just on the independent ones, and tomorrow we'll hit the dependent and kind of combine them a little bit. So independent only today, but at least you know what's coming up next. All right, two events are independent if the outcome of one has no effect on the occurrence of the other. For example, if you toss a coin 2 times, if you toss it once, let's say you get tails, that outcome has nothing to do with the next time you toss it. You could get tails again, you could get heads, still have the same probability of getting either one, even though you've already tossed it once. It makes no difference in how they have taken place. Now, the way you do probability is if A and B are independents, then probably they're both A and B. That's the big door today, and. Remember the last couple of days I told you whenever you see the word or, that means you're going to add. Or means you're going to add. When you see the word and, I want you to say, I've got to multiply. I've got to multiply probabilities, which is what you do. If they're independent and one has no effect on the other, multiply the two probabilities together. Or three if there's more than two. Okay, let's check one out here. For a fundraiser, a class sells 150 raffle tickets for a mall gift certificate and 200 raffle tickets for a booklet of movie passes. You buy 5 raffle tickets for each prize. What is the probability that you win both prizes? Well, that's an and. You win both. You win one, both means and. You win the mall gift certificate and the booklet. Well, since you bought 5, you have a 5 out of 150 chance to win the gift certificate to the mall. You have a 5 out of 200 chance to win the gift certificate for the movie passes. And you just multiply your two probabilities together. This one's really I'm going to simplify them. That's 1 out of 30. That's 1 out of 40. So you really have 1 out of 1,200 chance of winning both, which is probably not going to happen, but you never know. Maybe it's your lucky day. All right, but that's, again, independent. You just multiply the probabilities together. Hopefully not a real big deal there. All right, in a BMX meet, one heat consists of 8 competitors who are randomly assigned lanes 1 to 8. Like a horse race, anything else. They give you a lane or a track meet. You're in lane 1, you're in lane 2, lane whatever. What is the probability that a racer will draw lane 8 in the 3 heats in which the racer participates? Okay, so that means you're getting lane 8 and lane 8 and lane 8. So it's really this. It's really like probability of A and B and C. So it's going to be 2 different multiplications. Basically, you have a 1 out of 8 chance of getting lane 8 the first time, and because the first race has nothing to do with the second, you get a 1 out of 8 chance of getting lane 8 again, and because the third one is not affected by the first 2, you get a 1 out of 8 chance of getting it again. So if you multiply that out, you get 1 out of 512. So again, not very likely you'll get lane 8 every single time, but it's possible because it's bigger than 0. So let's look at one more, and we're done for the day. Okay, one more here, a tad bit more complicated, but I think you got this. Let's see what we do here. While you're riding to school, your portable CD player, stop. Do y'all even know what that still is, a portable CD player? Like a Sony Walkman? Probably don't, but anyway, this probably is from back in the day. Your portable CD player randomly plays 4 different songs, 4 different songs from a CD with 16 songs on it. What is the probability that you will hear your favorite song on the CD at least once during the week, which is 5 days because it's a school week? Now, here's the deal. I want you to start figuring this out. When you see the words at least once or at least one, I want you to think compliment right off the bat. So what I'm going to do instead of doing, probably hearing the song and doing all this work, I'm going to find out what the probability of not hearing the song is, of not hearing your favorite, which is only one song, by the way, not hearing that song. And then I'm going to subtract it from 1. So I'm going to end up doing 1 minus that. Do the complement because it's so much easier. So anytime you see at least one or at least once, think complement, do 1 minus the opposite of it, which is not hearing the song. Now, here's the hardest part of the problem. What are the chances that you don't hear the song, your favorite song? Well, here's what it is. These are all the different combinations of songs you could hear on your way to school. There are 16 songs. It's going to play 4. Those are all the combinations of the songs that you could hear. Not hearing your favorite is picking 4 out of the 15 that are not your favorite. Okay, so the reason I picked 15 on the top is because there's 15 songs that are not your favorite. You only have one favorite. So this is the number of ways you could hear all the songs except for your favorite if you hear 4. These are all the ways possible, period. All right, so if I'm going to do the real problem now, probability of hearing my favorite at least once. All right, I'm going to pick hearing song, my favorite song, at least once. I'm going to do 1 minus this that I just came up with. Okay, and that's the hardest part of coming up with this right here. If we can get that, the rest of it's not too bad, if you remember how to do complements, obviously. So I'm going to punch that straight in my calculator, just as I see it, and I get 0.763. So, probability of hearing my favorite song at least once, pretty darn good. Probably going to hear it, like 76.3% chance I'm going to hear that song. So, hopefully that made a little bit of sense to you. The first two especially should have been really easy. The last one I get was a little bit tougher. We'll work on it tomorrow. As always, we'll see you there and we'll get it.